This is the Field Spec 3 that belongs to Western Carolina University.
All right, let's open it up.
Yep. This is what you'll find when you open it up. We've taken out most of the contents, but the most important content is this piece right here. This is a fiber optic cable that is very expensive to replace. As you can see, there's a whole. It's like $1,000, I think.
And the total machine costs what?
This whole unit was about $78,000, so we definitely want to use great care when we're unpacking it. We've taken out some of the other items, like the laptop and the cables, but when you unpack it, this is how you'll find it. So I'm going to lift this up by the straps. No, I'm not. Yes, I am, very carefully. I'm going to lay this down with the backpack straps on the ground. I'm going to unclip 5 plastic clips. Flop this open.
Do you have to take the thing out though? Can't we just hook it up?
We can just hook it up. But when you're using this in the backpack model, you want this to be on your non-dominant handed side. This is the fiber optic cable that is packed on top of the unit. This should not be coiled with a diameter of less than 5 inches. So I'm carefully taking this out, and I'll show you how to use this. This is the fiber optic cable that has 59 strands in it or something like that. And the instructions said for every strand that is broken, you lose 5% accuracy. But this lives in this pouch right here. So I'm going to pack this back up. Just tighten it down.
So we've been charging the battery overnight.
Got a green light.
This is a field instrument, so it's designed to be at least marginally portable.
Yeah. So I'm going to start hooking up some of these connectors. I've connected the battery supply in the pouch, and now I'm going to connect the power supply to the field spec unit, which is on the other side. Okay, so here's the power supply. This just spins down on it. This collar. I'm going to connect the Ethernet cable to the computer. We've charged the laptop completely overnight. Just hook up the Ethernet cable. We'll wait to do this actually.
Because you'll have to put it on.
Yeah, exactly. Yeah.
Let's get the gun connected up. So the fiber optic cable end, which you can kind of see here. Let's see if we can get it to focus on that. Nope. Anyway, plugs into the back of the gun, which is the gun doesn't actually do anything. It's just a passive object. But you thread this thing in. You have to get it to come out the tip, the hole in the tip there. So Adam, we'll try that out. Do you want to pull that thing off, or is it not worth it?
Yeah, I think it's okay.
This is kind of like in The Matrix when you learn Kung Fu. Right, that's good, right? Is that fastened in there in any way? It just sits?
No, it's not. It just sits, yeah.
Right, cool.
Trigger.
Oh, yeah. And the trigger button is just for when you want to save a spectrum. It's actually continuously reading spectra. Oops.
I'm left-handed, so I'm going to put this on this side so that I can shoot with my left hand.
All right. So they're going to put it on now. Shannon's holding on to the trigger so that we don't snap the cable. So it's the belly board is clipped in from the top and it has Velcro to support the laptop. That's the only place it's clipped?
Yeah, it's got a waist strap, but that's separate.
Oh, okay. So we've attached the Ethernet cable here, and I'm just going to thread it around and plug it into the spectrometer here. There you go. And we can just let that hang? Is that right?
Mm-hmm.
Okay.
So first we'll turn on the spectrometer. It's over here. On button's right next to the Ethernet switch. So you can hear it start to fire up. The image sensors have to be cooled, so it may not be a bad idea to let it run for a bit to heat up or to achieve a stable temperature before you start reading. But the black, what's it called, the dark current compensation should take care of it, so I guess it's not a big deal.
So now I'm going to turn on the laptop. Second. So here on the laptop, I'm going to double click on the RS3 Cube logo. Right? Looks like this. It's the second one down. That's going to open the software. So the sequence was power on the spectrometer, power on the computer, now open the software. Now I can see that the spectrometer is collecting data.
You take a reading, well, it's reading continuously, right? And if you want to save a reading, you press the button here, and it should make a beep noise.
Which it doesn't. Oh,
Maybe you just can't hear it. Oh, yeah. Try again. So that's saved a spectrum. You can monitor the spectrum continuously here. Wow, that looks great.
Yeah, it does. This is water vapor in the atmosphere at 14 something, right?
Yeah, yeah. Or no, there should be a drop. But maybe you're right. I don't know. Anyway, so we need to calibrate it. So what you have to do is, there's two ways to calibrate. You want to calibrate the maximum amount of light that you'd be able to get and the minimum amount. And you can actually both at the same time. So there's the minimum is called dark current, and what it does is shuts a flap over, it closes a shutter, which cuts off the light entirely. So you don't even have to be pointing it anywhere. But when we do the white reflectance, it will do a dark current calibration, because it's always doing dark current calibrations as much as possible to establish a good baseline. So if we click on white reflectance, it will do both at the same time. So if Adam points this thing straight down at the light, if you could get it even closer, that'd be better, but I think it's all right. Just sight it, get directly over, and sight it directly down. It looks dangerous. Maybe I just do it.
Alright, I got it.
Okay, so there's a little a bubble gauge here, so if Adam's directly over it and the bubble gauge is exactly flat, then that works. Otherwise, obviously, you can just point the thing and it should, it should work. So this is a material which reflects 100%, or very, very close. It's like 99.98, and across the whole wavelength range that we want. So as he points it there, as he presses white reflectance, which is the WR button in the top corner, it actually starts with a dark current, and you will see the progress bar. We'll do this all indoors. But just keep it pointed at the plate for when it switches over to do the white reflectance. And now it's doing the white reflectance test, and now it's done. So now it's calibrated basically, and you can kind of wave the thing around now or point it down at the ground. Just point at the same geometry as you did the test, and the lighting should be the same. So you now have your top and bottom references. So now whenever you encounter something you think is interesting or relevant, say like this piece of stone over here or an area of grass, and you want to save that, just press the button and wait for that noise. There you go. Probably from the same angle though. The reflections, the angle of the sun.
That's pretty cool.
You're gonna get like a yellow leaf.
Yeah.
Of course, all the visible stuff is checked out.
I know.
So,
I think we're good outside.
oh, okay. Say 15 minutes later, the light could be very different. So you want to repeat your white reflectance reference calibration. It will go through the dark current automatically. And now it's about to start the white reflectance. Or white reference. So it's done. And now it's reading again.
So you first press the WR button here, and it will start with a dark current measurement. Once it's done with that, it will do a white reference. This is where you want it pointed at the tile. And now it's done. And now you can see that it will continue to take new spectrum references.